Welcome to Spring LIB.
Hi, in this question, we are given that NaOH is added to HCN solution and they react to produce NaCN and H2O. We are given with concentration and volume of both NaOH and HCl in this manner, and we are asked to calculate the pH of solution. First of all, we will calculate the moles of NaOH and HCl. We know that moles are given by molarity into volume. We can substitute the values for both here. In this manner, now we can eliminate the common liter unit from here, and on solving this we are getting the moles of NaOH is equal to 0.005 mole and moles of HCN will be equal to 0.0102 mole. We can see 1 mole of NaOH reacts with 1 mole of HCN to produce 1 mole of NaCN and 1 mole of water. Therefore, here we can say that the moles of HCN remains will be equal to moles of HCN minus moles of NaOH, and the moles of NaCN forms will be equal to moles of NaOH. Now we can substitute the values here. In this manner, on solving this, we are getting the moles of HCN remains in the solution equals to 0.0052 mole. Now we can say that the total volume of solution is equal to 0.010 liter plus 0.030 liter. On adding, we are getting the value 0.04 liter. Here we can see we are having a solution that contain a weak acid, that is HCN, and the conjugate base CN minus, or we can say the salt NaCN. Then we can say we are having an acidic buffer solution, and we can calculate the pH of buffer solution using the Henderson-Hasselbalch equation. Therefore, first of all we will calculate the pH of solution, before which we need to calculate the concentration of HCN and NaCN, as the concentration will be given by the moles over total volume. We can substitute the values for both here. In this manner, on solving, we are getting the concentration of HCN equals to 0.130 mole per liter, and concentration of NaCN is equal to 0.125 mole per liter. Now we can say that the formula of pH is equal to pKa plus log concentration of salt, that is NaCN, divided by concentration of weak acid, that is HCN. Now we can substitute all the values here. In this manner, and on solving this, we are getting the pH of solution equals to 9.28. We are asked to calculate the pOH value. It will be equal to 14 minus pH. We can substitute the values here. In this manner, on solving, we are getting the pOH of solution equals to 4.72. This is the answer. Hope you have understood the solution. Thank you.